Hello, I'm Tom Nickel, and I do technical marketing and sales at Wanova. What I'm going to do today is take you through a PowerPoint that outlines the Wanova Mirage solution, and after that we'll segue into a demonstration that shows you some of our functionality firsthand. Getting started with our presentation here, you can see our general architecture, and what this depicts is basically two sides of the Wanova solution, the end users on the right and the Mirage server in the data center on the left. In terms of end users, what we're really adding is disaster recovery, and we do that by storing virtual copies of each endpoint in the data center. This really enables IT to restore a broken, lost, or stolen device to its exact working state, which means minimal user downtime. The other great thing about Mirage is that because we are an installed client and not a hypervisor, end users actually get to leverage the full compute power of their devices. This means that powerful applications and multimedia and things like that, things that traditionally don't run well over VDI, are actually empowered to run natively and seamlessly on these devices. In terms of the data center, what we're providing to IT is the image management piece, whereby IT is able to build corporate images and apply them to their end user devices. And this really helps facilitate things like corporate compliance and patch management, application management, all those tasks that traditionally take up a lot of time of an IT departments. In terms of the server itself, one Mirage server can support up to 1,500 endpoints. If you compare that to VDI, that same server in a VDI environment would probably only support up to about 20 or 40 endpoints. But because Mirage is leveraging the native computing power of the endpoints, the kind of server-side computing power that's necessary for VDI is completely unnecessary for a Mirage deployment, and that's how we get such high capacity out of just one server. And if you need more than 1,500 endpoints supported in a Mirage deployment, you can cluster Mirage servers together and put them behind a load balancer for increased capacity. Now, in terms of managing your Mirage server, the way you do that is via the Mirage Management Console, which is really just an MMC snap-in. You can use it to manage one or many Mirage servers, so you've got that one pane of glass thing going on, and you can install it locally on the Mirage server, or you can install it remotely. You could install it on your Windows 7 laptop as an IT administrator, for example. Now, on the client side of things, our installation package is literally a tiny 2 megabyte MSI package. And the great thing about Mirage is that we offer complete flexibility regarding what endpoints are used with our system. We support desktops, we support laptops, we support virtual or physical devices, and I want to emphasize that Mirage is not and does not require a hypervisor, which can actually help alleviate a lot of the doubling up on Windows licensing issues that occur sometimes when you're using hypervisors. So when the Mirage client is installed on an endpoint, as we kind of touched on earlier, what happens is a virtual copy of that endpoint is staying synchronized with the data center. But we aren't just storing things arbitrarily. We've kind of broken up the way we store these endpoints into three logical layers. The first layer is the base image, which comes from IT, and that contains the OS, patches, corporate applications, etc. The next layer is the machine and user app layer, which contains the applications that have been installed by the end user. And lastly, the user data and settings layer, which contains basically all of a user's personalizations and user files like My Documents and things like that. And now, because of this layered architecture, one of the cool things that Wanova really empowers is it allows IT to fix problems with a scalpel instead of a sledgehammer. Because now, instead of having to fix an entire device or diagnose the symptoms of a problem on a device, you're really empowered to fix things at the layer level and not just at the endpoint level, which can save a tremendous amount of IT time. You're not always having to format and reinstall operating systems and things like that. You can really get down granularly here. So by now, however, you're probably worried about the storage and network costs of something like this. But thankfully, Wanova thought this through ahead of time, and we've kind of gone out of our way, actually, to optimize our storage and network operations. So on the storage side, we offer file and chunk level deduplication, which means that we only store things once in the data center. And as an example, when you add your first Windows 7 endpoint to Mirage, we'll store a copy of Windows 7. But when you add a second Windows 7 endpoint to Mirage, we'll recognize that most of that is already stored in our data center, and instead of storing it again and over and over and over, we'll just keep track of who else has a copy of it. So ultimately, you end up with basically one copy of Windows 7 in the data center, and kind of like a manifest of who has that. Now on the network side, which is equally important, we do network transfer deduplication, which means that anytime a network operation is performed via Mirage, we compare the source and the destination, and we compute the delta between those two objects. And what that means is that, let's say you're applying a base image update to an endpoint that has a few Windows patches. We'll compare the endpoint to the base image. We'll recognize that 95% of the Windows files already exist on the endpoint, and then we'll only transfer the differences across the network, which in this case would only be a few patches down to the endpoint. So this ends up saving a tremendous amount of bandwidth. And on top of all of this, anytime we perform any network operation, we compress the data before we send it. So we've literally gone out of our way to save and keep your storage costs down and your network costs down, and make sure that everything we do is in the most effective way possible from a storage and network level, especially since a lot of these operations we've intended to be performed over a WAN and not over a LAN. So we've really put a lot of time and effort into these deduplication technologies. All right, that actually concludes our overview of the Wanova Mirage software. So let's move on to a live demo. Today, we're going to do two Mirage demos for you back to back. For the sake of these demos, we'll be using our VMware environment for our endpoints. The first demo we're going to show you is how to take a device that has been lost, stolen, or broken and restore it entirely to a new device. For this demo, we'll use two endpoints. The first endpoint, Demo System A, is a normal end user's device. You can see this user has a bunch of their own files, they have their own desktop wallpaper and shortcuts, and they have Office installed. All in all, this is a pretty standard end user device. And so to simulate this device being lost, we're just going to shut this VM down. So let's go ahead and close out of Word and go ahead and shut this VM down. And then once it's shut down, we'll move over to Demo System B and talk a little bit about that system. So we're now on Demo System B. What you can see here is that it's a completely blank Windows 7 endpoint. There's no user data here. There's no installed applications, nothing like that. It's literally just a blank Windows 7 endpoint with the Mirage client installed on it. Now, what we're going to do in order to get all of the data from Demo System A down onto this Demo System B is open up the Mirage Management Console, and we're going to go into the Pending Devices queue. This is where all devices that have been added to the Mirage system start out. We're going to right-click it and select Assign, and then we're going to do Reassign an existing CVD. Once we do that, we're going to select Demo System A from our options here, and that basically means that we want to apply Demo System A to Demo System B, which is what we're working on right now. So we can click Next through the rest of these options, and then this is basically going to begin the restoration process once we click Finish. Now, the first thing that you should notice happen on Demo System B is a little balloon pop-up, and that little balloon pop-up is going to alert us that the restoration process has begun taking place on Demo System B. And what that basically means is Mirage is going to compute the delta between Demo System A and B, and then it's going to prepare itself to send from the data center all of the stuff we want down to Demo System B so that our end user can begin using it again as if it were just device A, which has been lost, broken, or stolen. Now, to save a little bit of time in this demo, let's go ahead and skip ahead to the end of the download phase for this particular operation. If you look here, you can see that only around 430 megabytes is getting transferred to Demo System B from our data center, and that's because Mirage figured out that Demo System B and Demo System A both had Windows 7 installed, and thus it was unnecessary to send that data back down to Demo System B during this transfer. So instead, we're only going to send what doesn't exist, in this case, things like Microsoft Office and any other installed applications or user data. Once the download completes, the user will be prompted to reboot their machine. Once this happens, our endpoint will enter what we call the pivot phase. This is where the data that Mirage downloaded from Demo System A's backup in the data center will get merged onto Demo System B. And once that reboot completes, Demo System B will basically be an exact clone of Demo System A, and our end user can get back to work pretty much immediately. So we've rebooted successfully and noticed that we're still on our Demo System B VM, but notice that Demo System B is now identical to what we had on Demo System A, which for the sake of this demo has been lost or stolen or broken. So if we click around after the restore, we can see that the desktop shortcuts and wallpaper are here, all of the user files are here, and my applications are still working fine also. So basically with just a few clicks in the Mirage Management Console, some downloading, and a reboot by the end user, we have successfully gotten our end user back up and running after their device was lost, stolen, or broken. That actually wraps up our first demo. So for our second demo, what we're going to show you is how to fix a broken application using our image management tools. So what we're going to do now is we're going to skip over to Demo System C, which is basically just another end user device. So again, note the desktop wallpaper and shortcuts and the user files. This time, however, let's try and open one of our user spreadsheets. What we can see here is that Excel is broken and our end user isn't really even sure how it happened. It basically just stopped working. So after calling IT, this end user's IT admin has found their endpoint in the Mirage Management Console and is going to perform what's called a base image enforcement on this endpoint. That means that Mirage will basically compare the endpoint with the base image, find the pieces that are missing or corrupt, and fix those pieces. And when those pieces are fixed, the user will reboot, and any applications that are contained in the base image, like Excel in this case, will be fixed also. One of the other really cool things about Mirage, however, is that when you're doing these operations, in this case fixing a broken application, your end user is actually free to continue working while this takes place. So to show that, let's go ahead and open up Word, type up a sentence or two, and save this Word file to the desktop. And what's cool is that once this operation completes, this Word file will still be here after we've fixed Excel. Okay, so once again, let's skip ahead to the end of this downloading process. Our end user has been prompted to reboot, so let's go ahead and do that. And once we do that, we're once again going to enter the pivot phase. So the pivot phase is basically common to any Mirage operation we do that requires a reboot. So as you recall, the pivot phase is where we'll basically take all the data that Mirage just downloaded and we'll merge it onto this endpoint to accomplish our mission. In this case, enforcing a base image to fix a broken application. And like we've said a few times also, the other cool thing about how Mirage does all this is that when we download stuff from the data center, we take a lot of special care to make sure that the only stuff we download is the stuff that's needed. So we always compare the source and destination and then compute the delta and then send that instead of an entire image every time you do something like this. Excellent. So as you can see, our endpoint has rebooted, and the first thing we can see here is that our desktop wallpaper and shortcuts are still here exactly the way they were, and Mirage is alerting us to the fact that our system has been restored. The other thing you can see is that the Word file I created while this was taking place is also here on my desktop still. So let's open up that same spreadsheet and make sure that Excel has been fixed. And here we can see that Excel is opening exactly the way it should. And what we've shown here is that IT was basically able to fix this user's broken application without any diagnosis, with a tiny amount of user downtime during the reboot, and with just a few clicks in the Mirage Management Console. And with that, this concludes our overview and demos of the Wanova Mirage solution today. On behalf of myself and Wanova, thank you for taking the time to view this presentation, and if you have any questions, please don't hesitate to contact us. Thank you.